Hi, this is Javin Kharo, a chemical engineer by profession, going to continue our today's topic, thermal cracking. Now, what's that? Thermal cracking is a chemical process that uses high heat and pressure to break down large hydrocarbon molecules, like those in crude oil, into smaller, more valuable ones, such as alkane, like ethane, and smaller alkane. It works breaking covalent bond in the molecule, which form unstable, unpaired, free radicals that react to form new lighter molecule. Why? It can produce significant amount of coke, a heavy residue, is a key process in oil refining for increasing the yield, lighter fuel and product. Now, how it works? High temperature and pressure. Large hydrocarbon molecules are subject to high temperature, typical 450 to 900 degrees centigrade pressure up to 70 atmosphere. Covalent bond breaking. Intense, the heat breaks the strong covalent bond with long chain hydrocarbon molecule. The free radical formation. The broken bond result in formation of free radical. They are highly reactive molecule unpaired electron. Molecular rearrangement. The free radical react and rearrange themselves, leading the formation of salt chain hydrocarbons, include many alkanes. Key characteristic: no catalyst. Unlike catalytic cracking, thermal cracking does not require a catalyst. Product yield higher percentage alkane compared to other cracking process, coke formations. Significant reduction. Thermal cracking is the unavoidable formation of coke, the solid carbon residue. Complexity. The process is less selective than catalytic cracking, produce more random and diverse mixture of the product. Application. Petroleum refinery. The primary application of thermal cracking is convert heavy, low-value refinery residue into lighter, more valuable product like gasoline and alkane. Plastic production. The alkane produced, such as ethane, essential manufacture of polymer, they are used to make plastic. Now, key factor influence thermal cracking. Thermal cracking is a process used petroleum industries to break down large hydrocarbon molecules into smaller, more valuable, applying heat. This process crucible for producing lighter fractions such as gasoline, diesel, and other petrochemicals. The conditions of thermal cracking are influenced. Several factors include temperature, pressure, residence, time, and type of feedstock. Underlying the condition, essential optimize process and achieve desired product yield. Below, the explore factors that influence cracking and interact product of the desired outcome. Now, the key points are temperature. Temperature is one of the most critical factors. Thermal cracking. Higher temperature are the energy needed to break the chemical bond in larger hydrocarbon molecule. Now, optimal range. Thermal cracking temperature between 450 to 750 degrees centigrade. Exact temperature depend type of feedstock and desired product. Now, its impact. Higher temperature increases rate of cracking, leading production lighter hydrocarbons. However, high temperature lead unwanted side reactions such as coking. Now, pressure. Pressure affect phase of hydrocarbon and rate of cracking reaction. Lower pressure favor formation gaseous product. Higher pressure lead the more liquid product. Optimum range. Thermal cracking conduct low to moderate pressure, typical 1 to 10 atmosphere. The choice of pressure depends desired product and the specific cracking process used. Now, impact. Lower pressure enhance formation lighter hydrocarbon, also increase risk of coking. Higher pressure reduce coking, decreases yield lighter product. Residence time. Residence time are duration of feedstock exposed cracking condition, crucible controlling the extent cracking and distribution of the product. Optimum range. Residence time widely depend on process ranging few seconds, several minutes. Shorter residence time use process like steam cracking, while longer time may use delay coking. Impact. Longer residence time allow more extensive cracking which yield lighter product. However, excessive residence time Overcracking produce unwanted byproduct and increase cooking. Fish stock for composition. Now its role. Type of hydrocarbon fish stock significant influence the cracking process. Different fish stock have varying molecular structure which affect their cracking behavior. Common type of fish stock are include naphtha, gas oil, residue, lighter fish stock. Naphtha crack more easily and produce higher yield, lighter product, while heavier fish stock residue require more several conditions, produce more byproduct. Impact. Choice of fish stock affect temperature, pressure, residence time, and heavier fish stock, higher temperature, longer residence time can be also increase risk of cooking and produce more complex product. Now, while traditional thermal cracking does not catalyze some of the modern process, such as catalytic cracking, catalyst to enhance cracking reaction, impact catalyst can lower the activation energy for cracking, allow process to occur lower temperature and pressure, improve selectivity, cracking process, leading higher yield, desired product and reduces unwanted byproduct. Now, reactor design. Design reactor use thermal cracking, influence efficiency, effectiveness. Reactor design affect heat transfer mixing, distribution residence time. Common reactor type include tubular reactor, fluidized bed reactor, delay cooking drum. Each type has advantage, disadvantage, heat transfer, residence time control, and easy of operations. Now, impact. Choice of reactor design affect temperature and pressure. Profile reactor influence extent cracking and distribution product. Proper reactor design essential achieving optimal cracking condition, minimize unwanted side reaction. Now, quenching is rapid cooling. Crack product stop further cracking reaction, crucible for controlling final product distribution. Quenching achieved using water, steam, and other cooling media. The method, rate of quenching depend on specific process and desired product select. Effective quenching help to preserve desired product distribution, preventing overcracking and formation of unwanted byproduct. Also help reduce risk of cooking in downstream equipment. Now, the condition of thermal cracking determine combination of temperature, pressure, residence time, fish stock, composition, reactor design. Each play crucible role, determine efficiency of cracking process, quality, final product, careful controlling condition, operation and operator can optimize cracking process, produce the desired mixed lighter hydrocarbon, minimize unwanted byproduct and operational issue of cooking. Now, factor affecting that define factor, role, optimum range and impact. First, temperature provide energy to break hydrocarbon bond. That optimal range 450 to 750 degrees centigrade. Its impact higher temperature increase cracking but may causes cooking. Pressure affect phase and rate of cracking reaction. 1 to 10 atmosphere impact lower pressure favor lighter hydrocarbon but may increase cooking risk. Residence time control extent cracking and product distribution. Second to minute longer time increase lighter yield but risk overcracking. Fish stock influence cracking behavior based on molecular structure. It affect naphtha, gas oil, residue. It can impact the lighter fish stock, crack easier, heavier ones require more several conditions. Reactor design that affect transfer mixing and residence time distribution. Tubular, fluidized bed, delay cooking drum. Its impact, efficiency and product distributions. Quenching repeatedly cool product to stop further cracking. Its affect water, steam, other cooling media, preserve product distribution and residue cooking risk. Now, thermal cracking is a process. Heavy residue hydrocarbon, they are decomposed, lower molecular and higher value hydrocarbon product under several thermal conditions. Absence of catalyst, it is very valuable process. Upgrading bottom to barrel can produce excellent conversion of vacuum and atmospheric residue integrated with other refinery unit. Thermal cracking process relatively cheaper as compared catalytic cracking process. Residue hydrocarbon cracking is often combined thermal crack to upgrade the bottom of barrel, provide high quality light and middle distillate, thermal cracking petroleum category, carbon rejection or residue conversion. Feed thermos cracking are vacuum residue, atmospheric residue and other refinery, hydrocracker, fluoride catalytic cracking, while major thermal cracking products LPG, gasoline, middle distillate, further high quality fuel oil and coke are produced residue feed, but thermal cracking products are highly olefinic, aromatic and high sulfur content. They require hydrotreatment, improve property, desired product specification. Now difference between thermal cracking and catalytic cracking. Thermal cracking is the process breaking down large compound of small compound at high temperature and higher pressure, while catalytic cracking is the breakdown large compound into small hydrocarbon using acid catalyst. Thermal cracking involve cracking apply high temperature and pressure. Catalytic cracking are catalyst along with moderate temperature and pressure. Thermal cracking temperature use thermal cracking range between 500 to 700 degrees centigrade, while catalytic cracking are range between 475 to 530 degrees centigrade. Pressure pressure used in thermal cracking 70 atmosphere. Catalytic cracking pressure used are 20 atmosphere. Now applications. Thermal cracking use wish breaking, thermal gasoline production and delay cooking, while catalytic cracking are used olefin and octane fuel with octane number between 67 to 70. Now conclusion. Thermal cracking and catalytic cracking are major process used in petroleum refinery order to obtain useful product, crude oil. Both techniques have advantage as well as drawback. Main difference between thermal cracking and catalytic cracking. Thermal cracking use heat energy for breakdown compound, where catalytic cracking involve catalyst to obtain product. Okay guys, this is up to our today's topic thermal cracking. I hope you get sufficient knowledge after watching this video. Next Sunday we have covered some another chemical engineering topic. Till then goodbye. Do take good care of yourself.